Hi everyone, welcome to Math World. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 5, which is the Probability and Statistics 1 for February-March 2021, and the code is 9709/52. So let's move on to question number 1. Question number 1. A fair spinner with 5 sides, number 1, 2, 3, 4, 5, is spun repeatedly. The score on each spin is the number of the side on which the spinner lands. A. Find the probability that a score of 3 is obtained for the first time on the 8th spin. So obviously this is geometric distribution. Okay, so you need to get a score of 3. That means probability of getting 3, which is P, equals to 1 over 5. Okay, that means the Q is going to be 4 over 5. Alright, so it means that the score of number 3 is obtained for the first time of the 8 spins, means that first 7 spins, 1, 2, 3, 4, 5, 6, 7, all these will be failures. So 7, Q, and then the last one is going to be P. Okay, so now the probability is going to be, the Q is with probability of 4 over 5, and there are 7 times, so it will be multiplied to itself for 7 times, therefore it is power 7 of 4 over 5. Then you multiply with the P, which is 1 over 5. That means the probability at last it will be 0.0419. So this is geometric distribution. Okay, now B, find the probability that less than or fewer than 6 spins are required to obtain a score of 3 for the first time. So now we know that, okay, for the score of 4 less than, score of 3, okay, that means the probability now is Px less than 6, because fewer than 6 times. So it is same as Px less equals to 5. We have a formula here. For the geometric distribution, if Px less equals to small x, it will be 1 minus q to the power of x. Alright, this is for geometric distribution. So therefore, I will be getting 1 minus the q here is 4 over 5. Alright, so it will be 4 over 5 to the power of 5. And at last, you will be getting 2101 over 3125. And you can just calculate this correct to 3 significant figures, which is 0.672. So that's the solution for 1B. Okay, so now let's move on to question number 2. Georgie has a red scarf, a blue scarf, and a yellow scarf. Each day, she wears exactly one of these scarves. The probability that the 3 colors are 0.2, 0.45, and 0.35 respectively. When she wears a red scarf, she always wears a hat. When she wears a blue scarf, she wears a hat with probability of 0.4. And when she wears a yellow scarf, she wears a hat with probability of 0.3. Now, find the probability that on a randomly chosen day, Georgie wears a hat. Okay, so from here, I will show the tree diagram that it will be, you can see it clearly. So it means that basically there are 3 colors of scarves. The first is red, second is blue, third is yellow. So then 0.2, 0.45 probability and 0.35. Now, when she wears a red scarf, she always wears a hat, which means hat is 1. Okay, and then she wears a blue scarf, she wears the hat with probability 0.4. That means now here is 0.4, not wearing hat is 0.6. Then when she wears a yellow scarf, probability of wearing a hat is 0.3. So it means not wearing hat is 0.7. Now, on a chosen day, okay, she wears a hat. So it means that it can be one of these 3 colors of the scarves. So PH, it will be 0.2 times 1, or 0.45 times 0.4, which is wearing the blue scarf, or wearing the yellow scarf with probability of 0.35, then multiply with 0.3. Then from here, at last you will be getting 0.485. So that's the probability of 2A. Now B, find the probability that on a given day, Georgie wears a yellow scarf given that. So given that means conditional probability. She doesn't wear a hat. Means now P yellow scarf given that doesn't wear a hat. So now from the formula, okay, the conditional probability formula, that means if let's say, hang on please. That means if let's say you are given the conditional probability, it will be PA slash B, then this becomes PA intercept B over PB. Okay, that means here is PY intercept H bar over P H bar. So we will be getting Y intercept H bar is 0.35 times by 0.7 over PH bar. H bar means that it could be because of the yellow scarf or could be the blue scarf. So I have to add up these two multiplication. So you will be getting 0.45 times 0.6 plus 0.35 times 0.7. Then you'll be getting 0.245 divided by 0.515. So at last the answer will be 0.476. So that's the probability of B. Okay, now let's move on to question number 3. The time spent by shoppers in a large shopping center has a normal distribution with mean 96 minutes and standard deviation 18 minutes. A. Find the probability that a shopper chosen as random spends between 85 minutes and 100 minutes in a shopping center. Means that now this is X is normally distributed. The mean is 96, standard deviation is 18. So we always write variance. Therefore, it is square of 18. And now you need to count probability that X between 85 and 100. Okay, so now we need to standardize it by using the formula. If let's say your X is normally distributed with mean, mu, variance, sigma squared, then the Z is going to be X minus mu over sigma. Alright, so that means now here I have to minus mu, minus 96 from 85, then over 18, because 18 is our standard deviation. So then less than Z and less than 100 minus 96 over 18. Then from here, when you simplify the values, you will be getting negative 0.611 and 0.222. So once you reach this step, it's compulsory for you to sketch a graph. Then you will see the region clearly. So it will be negative 0.611 to 0.222. So this is your region. Now what I'm going to do for the next step is I will just use PZ less than 0.222 minus PZ less than negative 0.611. So that means this is PZ less than 0.222 minus PZ less than negative 0.611. And then the second probability is not available in the table, therefore I will draw another graph, or I will sketch another graph just to show the region of the second probability. So this region, negative 0.611, okay, I have to flip it to the right side. It will be 0.611 positive, and it becomes more than. So in order to get the orange color region, so it is same as finding the green region. So the green region here is same as total probabilities 1 minus PZ less than 0.611. That means now I will be getting PZ less than 0.222 minus 1 minus PZ less than 0.611. And now you can just read the probabilities from the normal table. So that will be 0.5878 minus 1 minus 0.7294. Then at last, you will be getting the answer. So this is going to be 0.3172, and we always round up the answer correct to 3 significant figures. Therefore, it will be 0.317. So that's the solution for this question. Now, 88% of shoppers spent more than T minutes in the shopping center. Find the value of T. This is the part B. So which means now Px more than T is 0.88. Okay, so again we standardize it. So Pz more than T minus 96 over 18 equals to 0.88. Now I will sketch a graph. Since this is more than and the probability is more than 0.5, okay, that means the region should be, the value, the line to represent T minus 96 over 18 should be on the left side. So that this is the 0.88. And then my region, my line value will be T minus 96 over 18. So from the graph, obviously, this line, okay, it is a negative value because it is on the left side. Therefore, what we do is we have to flip it or reflect it to the positive. So when I reflect it, it will be negative of the existing value. And then my region will be the major region. So again, from here, I know that this is 0.88. So obviously, I can get this value from the table. Okay, so P z less than negative of T minus 96 over 18, it will be 0.88. Then I will write from table Pz less than 1.175 will be 0.88. Okay, then now we will just compare. So when you compare these two equations, right? So you will get one equation over here which is negative of T minus 96 over 18. It is 1.175. Then the negative can be moved to the other side. So T minus 96, it will be over 18. It will be negative 1.175. Then from there we can find the T. So the T is going to be 18 times negative 1.175 plus 96. Then at last you will be getting 74.85. And now I round up to 3 significant figures. That will be 74.9. So this is the solution for part B. Now for question number 4, the random variable x takes the values 1, 2, 3, 4 only. The probability that x takes the value x is kx times 5 minus x, where k is a constant. A, draw up a probability distribution table for x in terms of k. Okay, so Now from here I will write Px equals to small x equals to Kx bracket 5 minus x. Then the x will be 1, 2, 3, 4. Alright, so from here the table is going to be x followed by the probabilities, then the x values 1, 2, 3, 4. Now when you substitute x by 1, okay, that means when Px equals to 1, I will get K1 5 minus 1. That means this is 4K. When Px equals to 2, that will be K times 2, 5 minus 2. So it will be 6K. When Px equals to 3, it's going to be K bracket 3, 5 minus 3. It's also 6K. And at last, when Px equals to 4, it will be K times 4, then 5 minus 4. Then you will get 4K. Okay, so just put all this in the table. Then I will get 4K, 6K, 6K, and at last 4K. So that's the probability distribution table for X. Okay, so that's the solution for 4A. Now for B, show that variance x equals to 1.05. So now, before we get the variance x, okay, we need to find the K values first. So we know that total probabilities is 1. That means now I add all these 4 probabilities and let it be 1. So now you'll be getting 4K plus 6K plus 6K plus another 4K equals to 1. So for the right hand side, it will be, for the left hand side, it will be 20K equals to 1. Then your K is 1 over 20. Now, we need to get the expected value first, which is EX. It is same as summation x px. This means each x you multiply with the p. Okay, which means you do all the multiplication first, then you add up. So I will write 1 times 4K plus, based on here, 2 times 6K plus 3 times 6K plus 4 times 4K. So total here will be 50K. And now I replace my K by 1 over 20. Therefore, this is going to be 5 over 2. That is my EX. Now, for the EX squared, it will be summation x squared times p, which means all your x here, okay, all these are the x values. All those x here, you just square it. The rest remain. Then you will be getting all these terms. And now when you simplify, this is going to be 146K. And replace the K by 1 over 20. So then you will be getting 7.3. Okay, at last, your variance x is EX squared minus square of the EX. That means this is going to be 7.3 minus square of 5 over 2. Then you will be getting 1.05. So we have shown the variance x. Okay, now for question number 5. A driver records the distance traveled in each of 150 journeys. These distances correct to the nearest kilometers are summarized in the following table. Draw a cumulative frequency graph to illustrate the data. Okay, so for the cumulative frequency curve, we need to get the upper class boundaries and also the cumulative frequency. Alright, so what I need to do here is I need to construct the table. So I will just write upper class boundaries. So upper class boundaries, the first one you have to add, right? That means it will be 0. Then now this will be your second class already. Alright, so your second class, the upper class boundary is 4.5. You get the average of these two values. So 4 plus 5 divided by 2 is 4.5. Then now for the next one, you get the average. It will be 10.5. Then get the average of 20 and 21. It will be 20.5. Average of 30 and 31. It will be 30.5. The average of 40 and 41. It will be 40.5. Okay, let me check. This is 4.5, 10.5, 20.5 is here, 30.5. Okay, here 40.5. Okay, then at last you get the average of the upper class boundary for the last class. It will be 60.5 because I will expect the next one is 61. Okay, based on the previous pattern of the values. Then now for the frequency is 12. So now we are getting cumulative frequency, capital F. So at first it is 0, then 12. 12 plus 16, it will be 28. So 28 plus 32, it will be 60. Then 60 plus 66, 126. 126 plus 20, it will be 146. 146 plus 4, 150. Okay, so that's why you are given 150 journeys here. So your final capital F should be 150. So now, when you look at this graph paper, okay, since your horizontal axis will be the upper class boundary, so I need to include up to 60.5. Okay, which means I will measure first. So if let's say here is 0, this is 10, 20, 30, 40, 50, 60. Right, this will be the upper class boundaries. Then you will get, you will have to label distance. Then the vertical axis is going to be the cumulative frequency, which is our capital F. So our capital F is from 0 to 150. Okay, or this is probably I will just write cumulative frequency. Now you have to check the skew. We need to include up to 150. Probably here is 20, 40, 60, 80, 100, 120, 140, and here is, okay, so I have to label 160. That means this is 160. So this is cumulative frequency. Which is a capital F. Right. So now we need to mark all the points. At first 0, 0. Then 4.5, 12. Okay, here is 5. Right. That means 4.5 is in the middle. And 12. So this is 10. That means here is 12. So 4.5. Okay. Then the next is 10.5, 28. So 10.5, 28 is, here is 30. So that means, alright, here. Then 20.5, 60. 60 is over here. 20.5. Then 30.5, 126. 126. 3 squares. And it will be 30.5. The next value 40.5, 146. 146 is here, the 40.5. Right. Then lastly 60.5, 150. 60.5, 150. 60. Okay, so these are the points. So now we need to join all the points to get the graph. Okay, so you need to draw a smooth curve. Right. Okay, my graph is not very smooth. Right, so this is our cumulative frequency curve. Okay, now B, for 30% of these journeys, the distance traveled is d kilometers or more. Use your graph to estimate the value of d. So 30%, right? D kilometers or more. That means we are counting 70% because of this word or more. So 70% means that 70 over 100 times 150. So that means it will be the data number 105. So now we need to refer to the graph. 105 is, here is 110. So 105 is in the middle, probably here. Okay, and then you read what is the value. So this is going to be 27. Right, so it's all based on your graph. So from here, I will write this is the D is almost 27 kilometers. I mean, no need to write kilometers. So D is almost 27 based on the graph. Okay, now part C, calculate an estimate of the mean distance traveled for the 150 journeys. So to count the mean, we need to find the midpoints and use the given frequency. So now I will count the midpoints. So how do we count the midpoints here? It's basically getting the average of the two numbers. Okay, so get the average of these two numbers. So means you plus together and divide by 2. That will be the M. Okay, so I will count all this together now and put them in a table. And then I will copy this frequency. This is my small f. So which means now my M, which is the midpoints, will be 2, 7.5, 15.5, 25.5, 35.5, and lastly 50.5. And then copy down all the frequencies. Okay, just for information, how do we get this 35.5? So 35.5 is counted by getting the average of 31 and 40. So 31 plus 40 divided by 2. You will get 71 divided by 2. Therefore, this is going to be 35.5. That is our M for this class. Okay, so which means your mean is summation Fm over summation F, which is 2 times 12 plus 7.5 times 16 plus 15.5 times 32 plus 25.5 times 66 plus 35.5 times 20, lastly 50.5 times 4. Then over total is 150. Okay, then here you will be getting 3235 divided by 150. So at last you will be getting 21.57. But then this is 4 significant figures. Therefore now I round up to 3 significant figures. It will be 21.6. So this is the mean calculation. Okay, now for question 6a. Find the total number of different arrangements of the 11 letters in the word caterpillar. So now CATERPILLAR. There are 11 letters. Out of 11 letters, you have 2 A's, then you have 2 R, and you have 2 L. Then here you have 6 letters. That means you have 5 others. Okay, and now the total arrangements. So number of arrangements. Since we are arranging all 11 letters, we start with 11 factorial first, but 11 factorial is not appropriate because 11 factorial means that you are given 11 different letters. But then out of 11, we have the repeating. So you have to divide by all the repeating letters, 2 A's, 2 R, and 2 L. Therefore, the answer for this is going to be 498,600. So this is the solution for 6A. Okay, now for the B, find the total number of different arrangements of the 11 letters in the word caterpillar in which there is an R at the beginning and N and R at the end. and the two A's are not together. Okay, which means here you got the R. Okay, give me 1 minute. And then now you have 11 letters. Don't forget, just now you have 2R, 2A, 2L. Okay, so means that now you see the let me write down the word first. Caterpillars. Caterpillar. So we have to write the R at the front and at the back. Okay, so make sure the two A's are not together. Means that now I exclude the A first, then I exclude the A, then the R already taken. So means that now I have to arrange the C. So then T, after that E, P, I, L, L. Okay. Then here you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So another 2 will be the A. What we need to do here is the A can be in any of these places. Okay, so from here, out of these 9 letters, okay, 1, 2, 3, 4, 5, 6, 7. Out of these 7 letters, we have two L's. Alright, that means now my number of arrangements I arrange the 7 letters, but then since there are 2L, so divide by 2L. And then now for the green arrow, it will be allocation for the A. Alright, so it can be A in any of the places. So now when you look at the green arrows, we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 green arrows, but then we need 2. Okay, so now I will just write 8C2. I use C here because you need just any 2 places or any 2 arrows for the A, and there is no difference between the 2 A's. So that's why we use the C. Okay, then you will be getting 70560. So that's the solution for part B. Okay, now C. Find the total number of different selections of 6 letters from the 11 letters of the word caterpillar that contains both R's, at least one A, and at least one L. Alright, so now here from 11 letters I have 2 A's, 2 R, and 2 L. Now from these 11 letters I need to choose 6. Out of the 6 now I must have both R. So 2R, then I must have minimum 1A and minimum 1L. Okay, which means now when I list down my possible selections, okay, that satisfy the green color, means that I might get 2R, then 1A, 1L, and then I have to choose 2 more. Okay, from 6 others. Here will be 5 others, 5 others. Then it could be, this is the first one, it could be I got 2R, then 1A, 2L. Then I need 1 from others. The third case is probably I need 2R, 2A, and 1L. So these are the 5 letters, I need 1 more, 6 letters. Or the fourth case, it will be 2R, 2A, and 2L. Okay, so for your information, This underline, these two underlines, all these underlines will be chosen from 5 others. Okay, so which means now, since the question is asking for selections, right, that means the arrangement is not important. What I need to consider for the first 3 cases is I just need to choose either 2 or 1 from the 5 others. So which means now my solution is number of selections. Since we have 5 other letters, therefore for the first case it will be 5 choose 2 because I need 2 others. Or second case is 5 choose 1. Third case also I need 1, and then for the number 4, this is the only one method to get the value, to get the selection. So from here I will be getting 10 plus 5 plus 5 plus 1. So at last it will be 21. So this is the explanation for the number of selections in this question. Okay, now next question number 7. There are 400 students at a school in a certain country. Each student was asked whether they preferred swimming, cycling, or running, and the results are given in the following table. So you are given the gender and the 3 activities. A student is chosen as random. A, first part, find the probability that the student prefers swimming. So swimming, it can be female or males. So now my probability is 104 plus 31 over the total students will be 400. That means here is going to be 135 over 400. Then at last you have to simplify it into either you leave your answer in fraction or decimal. So here I leave it in fraction, which is 27 over 80. So that is the solution for A, first part. Okay, now part 2, determine whether the events the student is male and the student prefers swimming are independent, justifying your answer. So for male, P male. Okay, male students, it will be addition of these 3 values, 31, 57, and 92. Divided by total students. So the total students 400. Therefore, this is going to be 180 over 400. And then when you simplify, it will be 9 over 20. Now, probability of student prefers swimming. So I will write P swimming. So it will be always over 400. So total of those swimming already counted just now, which is 27 over 80. Okay, I will just copy the answer from previous part. Now to check whether they are independent or not is basically P, let's say A intersects B equals to PA times PB. That means independent. Okay, so now I need to calculate what is the intersection probability first. So male intersects with swimming. So it will be male and swimming 31. So which means the probability is 31 over 400. Okay, so now I get the multiplication. Male, probability of male times probability of swimming. It will be male is 9 over 20. Swimming is 27 over 80. So when you calculate this value, it's going to be 243 over 1600. And this is not equal to 31 over 400. That means, okay, this is not equal to the intersection probability. Alright, since they are not equal, then the events are not independent. Okay, so that's all for this solution. Now, on average, at all the schools in this country, 30% of students do not like any sports. B. First part, 10 of the students from this country are chosen as random. Find the probability that at least 3 of these students do not like any sports. Obviously, this is binomial distributed. The n is 10. Do not like, here also do not like, so the probability is 0.3, which means P is 0.3, then the Q is going to be 1 minus 0.3, which is 0.7. So since this is binomial distribution, formula is NP, B and P. So probability of the X will be NCX, PX, Q, N minus X. That's why I've written down the Q. And now you need to count the probability that at least 3 do not like. So at least 3 is Px greater equals to 3. So Px greater equals to 3, you have to count from 3 until 10. That means it's a lot of calculations. So I will use the complementation rule, which is 1 minus all previous. So all previous means that it will be from 0 until 2. Okay, so this is same as 1 minus Px equals to 0 means that no success, which means all are failures. So I will get 0.7 to the power of 10, 10 failures. And then Px equals to 1 means that 10C1, 1 success, and 9 failures. Then Px equals to 2 means out of 10, 2 successes, and 8 failures. Therefore, you will be getting 1 minus 0.3828. Then at last, the final answer is going to be 0.617. So that's the solution of B part 1. Now, next question, part 2. 90 students from the country are now chosen as random. Use an approximation to find the probability that fewer than 32 of them do not like any sports. So, just now, X is binomial. 90 do not like the sports will be 0.3. Okay, so now since your n is large, therefore NP is 90 times 0.3. Then I will be getting 27. And the NPQ, it will be 27 for the NP. Then the Q is 0.7. So at last you are getting 18.9, which means now your initial distribution was binomial, now has been changed to or approximate to normal. The mean is 27 and the variance is 18.9. Okay, and now you need to count probability that less than 32. So Px less than 32. So for your information, when you convert the binomial to normal, that means you need to consider the continuity correction. Okay, which means you label 32, which is the x values, and then you list down the possible values for the x. Less than 32 means it could be 30 or 31. Okay, and then when you approximate to normal distribution from binomial change to normal, which means from discrete change to continuous, you have to consider plus minus 0.5 from the given x, which means it can be 31.5 or 32.5. But since this is less than, that means towards the left side. So obviously we have to choose 31.5. Okay, that is the interval. So PW less than 31.5. Then now we standardize it by referring to this normal distribution. So it will be PZ less than 31.5 minus 27 over square root of 18.9. Okay, then you will be getting PZ less than 1.035. And now right after this, our sketch a graph. It is symmetrical at 0, then the line is 1.035. And obviously this is less than. Less than means all this region. Then I will be getting the probability from the table, which is 0.8497. And now I round up to 3 significant figures, that will be 0.850. Okay, so that is the solution of this question. Alright, so we have come to the end of the video. Thanks for watching. Please subscribe to the channel if you enjoy watching my videos, and stay tuned for more upcoming videos. Thank you. Bye.